Hmm. So who had the question? Who had the question?
So I think there is
Hmm.
someone hand up.
Okay, Alex.
Sir, please, you said which place will you go first? But I didn't listen the places. I heard restaurant, and but I didn't hear the rest. So if you can,
Okay, restaurant. Something has
I think
come. Who else can continue?
I heard gym,
So
gym.
I heard Jim.
Jim. Okay. Who else?
Say, I heard you asking that where will you pass first?
Okay. Hey.
So I think it's because of your network. That is why. It's because of the network.
Say,
Yes, Posty.
so I heard you were talking about the data redundancy, and you were saying that if you are going to collect data from the market, the gym, and the restaurant, which of them will you pass first?
Hmm. Hmm. Are you please and please and please and please? If you did not hear something you are unsure, kindly ask.
Okay,
So,
sir.
like Posty said, and like Philip and Alex also said, what I asked was that with redundancy, multiple shops or stores would want to collect your data or multiple departments. And I was using a restaurant as an example. So a restaurant or a shop that has, let's say, a gym, they also have a salon, they also have something like, say, mm, well, so let's use the gym, the store, and okay, let's use a hotel rather. So a hotel that has a restaurant, a hotel that has a gym, a hotel that has a swimming pool, a hotel that has a shopping mall. These four places. If you are not using good IT equipment, what will happen is that when you go to the restaurant, they'll take your data. When you go to the gym, they'll take your data. When you go to the pool, they'll take your data. When you go to the um what's the name of the salon, they'll also take your data. And all this is money to somebody. And it's also time wasting. The time that they use to collect all these things is also time. So you have your data at all these four places. It's redundant. Redundant in the sense that all these four places belong to one hotel. So at best, what they can use a simple please, if you're not contributing to the class, kindly mute yourself. Thank you. So what they can do to prevent this data redundancy is by using a simple POS device, point of sale, where irrespective of where you find yourself in this hotel, you get to do payment seamlessly. And you can pick something from, let's say, the shopping mall and go and pay at the swimming pool. Why? Because everything is connected. And everything is connected to prevent this redundancy. And redundancy has a use. Redundancy has a use for distributed computing, not for our standard normal computing. Then another disadvantage is time consuming, especially when we are doing updates. This restaurant, this salon, the swimming pool, and all other these places. What this means is that should the customer wants to do an update of his or her records, it will mean that you have to do it at all these places. And all this is time, not only time, it also consumes resources, data that is super expensive in Ghana. And you can imagine trying to upload all these resources onto the platform for the client to enjoy. And so time consuming is there. Then lack of data integrity. And when we say integrity, we are basically referring to the update, the modification, the deletion of that data. Of that data. Sometimes if someone decides to move from one place to the other, if you've not moved it on both systems, it leads to data inconsistency, and that can pose a big challenge. Then flexibility is also another thing. Data is supposed to be flexible. By flexible, what it means is that it should be able to generate reports in real time. You should be able to sort of respond to queries in rapid time. But all this will not be possible if you do not have the right data. Security can also be an issue. Security can also be an issue. Why? Because there will be little control or little management of data because of the access to how that data is sort of promulgated or propagated. Sharing and availability can also be a problem. Sharing and availability. Right. So what is DBMS? We said database is a collection of related data. Then what is database management system? Anybody? Yes, ADJV.
Okay, so say the DBMS is used to organize data. It's a software that can be used to organize the data, the raw facts that have been collected.
Okay, thank you. Any other person? Rosie. Okay. Okay, Alex.
Please, the database management system is a system that can define your data, and then it can also do some updates.
Very well. Thank you. Franca.
Say, please, it's a system software that aids in the collection of the data.
System software.
Like it's a software that aids in the collection of the
Thank
data.
you. Thank you. DBMS can never pass as a system software. It is an application software. Right, so we use DBMS to define, to create, to maintain, and control access to our database. And some examples include MySQL, the Microsoft Access SQL Server, the FileMaker, Oracle, the Relational Database Management System, the DBase, Clipper, FoxPro, as well as the PostgreSQL. But for this class in particular, we will use the SQL server. Specifically, the MySQL workbench. That is what we'll use for this class. However, if it seems too advanced, we'll downgrade to Microsoft Access. And so those of you who have computers, those of you who have laptops, make sure you have MySQL workbench installed on it for our demonstrations. If your laptop is a dual core, then we'll just stick with the Microsoft Access for you. That is if your laptop is a dual core machine. Right, so specifically, we said the DBMS is used for manipulation. And when it comes to manip, or what my guys those days will call OManip, it simply has to do with the retrieval of data, the update of data, and this update can be in a form of adding and deletion. Then, of course, control of access to the records, as well as recovery. In some instances, should the system decide to crash or should there be a breakdown? So yes, what are the advantages of these database management systems over our conventional files? As the name suggests, they are advanced. And when we talk about advanced, we have less or controlled redundancy. Less or controlled redundancy. Because we have established that redundant data will always come with a lot of problems. To prevent that, you will need a good DBMS. Then with DBMS, all your data is integrated, which means you can easily generate what we call an ad hoc report. You can easily generate what we call an ad hoc report. Then improve data integrity. You get an up-to-date data. You won't get one database where somebody's house address will be the current house address, and in the system for another department, the person's address is his previous landlord's address. And all these things pose problems later. Then, of course, user productivity can also not be overemphasized, because with technology, people tend to sort of develop some passion for more work. Security too would also be a bit on the rise, and that is because for database management systems, access to the database is defined by your username and password. So without the good or the required username and password, you will not get access to the DBMS. You also get an in-depth information. Remember, in-depth required information. Required because anyone or any unscrupulous person with access can also get access to that database. Yes, I also mentioned easy generation of ad hoc reports is also there. When it comes to sharing, I don't joke about it. Anybody or any authorized person can enjoy it. Disadvantages, complexity. Yes, it is super complex. The functionalities makes it complex. We can also not overlook the cost issues. This cost that we are talking about is only the initial cost, but in the long run, when you are comparing DBMS to our traditional approach, the DBMS is far cheaper. Why? Because you have less path to now feed. You have less SNIT contributions to now pay. In fact, for DBMS, you don't pay SNIT contribution for the computer. Once you buy the computer, it becomes your own bona fide property. You enjoy it for life until you decide to go and change one or two things later. Then security issues can also be there. People can come and escalate their privileges. And by privilege escalation, what I mean is one day somebody can decide to say, oh, let me increase my right so that I can be able to do this, I can be able to do that. Then, of course, there is always the higher impact of failure. Why? Because for systems, a host of things can happen. Backups can fail. Fires can also catch up some issues. When it falls down, hard drives can also crash. The issue of privacy can also not be overlooked because somebody will always want to know everything. This knowledge is a breach of others' privacy issues. Then, in time, the size will grow. And once the size grows, it means you have to start looking for more space. Performance issues can sometimes also be a bane or a pain in the ass, and that is simply because the bigger or larger your database, you will need a lot of fine tuning. You don't do it well, you have a problem. You do it well, you have a system that works. Differences between the database approach and the traditional file system concept. Is there a figure? There is no diagram. Right. So for the database approach, we've just looked at the advantages and the disadvantages. Just know that for the database approach, the aim is to simply provide a way for us to store and retrieve data from the advantages that we have looked at. And like it or not, this has actually proved quite useful over the years. And because of that, a lot of institutions are using it. Even our insurance companies, they now have databases. Airlines do, bankers do, financial do, education do. And enterprise systems are also not left out. So, like it or not, the change has brought about a lot of satisfaction, a lot of profits, a lot of profits. So, like it or not, this is actually a good thing. Any questions? Any questions? Okay.
Yes, sir.
Yes, everything.
I have a
Okay.
question.
Okay,
Sir,
so sir.
I really want to take you back a
Shepherd,
little.
hold
When
on.
you
Shepherd, hold on.
okay,
Everything.
Okay, sir. So please, based on your explanation, I can say that the differences you can say DBMS is a stored data electronically in a computer, whilst the traditional file system is used to manipulate data on a paper format.
On paper, you cannot manipulate data, please.
They used to store data rather on the paper format, like using paper, like physical file.
But can you store data on a physical file? Everything.
Hello, sir.
Can you store data on a physical file?
You okay, so I was trying to explain that traditional file system, they used paper format.
Okay, okay,
They use
okay.
paper
So they
format.
use
Whilst
a data than
the
they store.
DBMS. Yeah, okay.
Okay, thank you. Shepherd,
yes, sir. Sir, you
please
were
go on.
talking about the disadvantages of the file use. I think you scroll back a little. When you were talking about the disadvantage, you did mention of complexity, about being a problem
Complexity.
of that. Please, yes, can you please throw more light on it for me to understand it better?
Right. Did you do complex numbers?
Yes.
So you did complex numbers.
Yes, sir. Yes.
Were they difficult?
Yes, like the meme, like the meme.
Hmm. Like the name. So yes, when we say
Yes.
something is complex, it means it's difficult. And by
Yes.
difficult here, we are saying that you need specialized people to create that database for you, and not just one person, because all of them have their roles to play. And even after bringing all these people together to come and create or design that software for you, in the end, you also need somebody to sort of manage or operate the software for you. That is in case you choose to say, okay, for me, I need to employ somebody to come and work on it. But if you choose to outsource, that is also fine. But in the end, you need somebody to work at the front end. You need somebody to work at the back end. Is that okay? For instance, when you
Okay.
were applying to UCC, you bought the form and they gave you a serial number and a password. So with
Yes.
that serial number and password, you are able to log in to sort of apply. That is what you call the
Yes.
front end. Then at the back
Okay.
end, somebody sat somewhere and downloaded all your application, all the documents that you uploaded, then went to be able to come and give you your admission.
Okay.
Is that okay? So you as
Yes.
an individual, before you were able to apply, you needed some form of small knowledge. And I know
Yes.
most people send it to the cafes, and the cafe guy will take some small coins from them. But I equally
Exactly.
also know people who did it on their phones. I know people who did it on their phones. And even if you go to the institution, those who sit in court at the back end to download all these things, they know what they are about.
Okay.
Is that okay? So looking at what
Yes,
happens
sir.
at the front end and what happens at the back end, that is why we are saying it is complex.
Okay.
So you can even imagine the one who built the software. Do you think he was a wizard? No. Is that okay?
Yes, sir.
And a
Yes, sir.
practical example
Thank
is
you very
the
much.
man who wrote this book, one of those who wrote this book, Dr. Edumazi, one of the sharks that when it comes to DB, we cannot forget. So that is why we say it is complex.
Thank you very much.
So failure to understand the systems will always lead to bad decisions. Yeah, you're welcome. Any more questions? Right. So components, elements, and users of DBMS. So these users will put them into two groups. Those at the front end, those at the back end. And when we get to front end people, I'll tell you so that we understand the complexities.
Yeah,
Right.
yeah,
So this database management.
huh? And again,
Right. So one of the components or the main component of all DBMS is what we call the engine. The engine. And the engine is what ensures that the DBMS works correctly, works perfectly. So in a nutshell, it is responsible for all the operations that the DBMS is supposed to perform. Then we also have what we call the query processor. And what they do is to generate reports for us instantly. Somebody will say instantaneously. So all you have to do is write a simple query and you click on it, you get a result. So 1, engine, 2, processor, and 3, forms generator. And for the forms are basically what we use to generate our inputs. So when you buy the admission form, they will give you what admission form, the last word, form. So they'll give you a serial number and a password that will log you in to fill the form. To fill the form. Yes. So the form is like an input device, which is supposed to take all the data from you and I to populate the database. So these are the 3 main components of all DBMS. Then we also have 3 elements of all DBMSs, what we call the data definition language, the DDL, the data manipulation language, the DML. Yes, I remember. Those of you who has ever watched Merlin, they mentioned DML inside. Some spiritual being in the movie, guys. Yes, so DML is also there. Then the DD, data dictionary. And please don't confuse this data dictionary with metadata. Metadata is data about data. Data dictionary is a collection of data, but as we move on, you get it, you understand it. Right. So let's start with the DDL, data definition language. This language specifies the data types and the structure, as well as the constraints of the data that is meant or that is to be stored in our database. The data types. Data types simply describes or simply tells us the type of data that we expect to see in the database. It also tells us the structure of that data that is meant to sit in that database. Then the constraints that we can do or that we can perform on that particular data. Then manipulation language. So for the OMANIP, what OMANIP does is that it tells it the sort of operations that we can perform on our data. Can we update it? Can we delete it? Can we select it? And can we retrieve data? All these are manipulative tactics or manipulative things that we can sort of execute or perform on our database. Then the data dictionary, which consists of the database metadata. Data dictionary consists of the metadata. So don't confuse the two. Right. So for the data dictionary consists of all this information, the names of all the tables in the database, the constraints. And when we say constraints, concept of keys, their relations to each other. Who owns the table? Who last updated it? Who last accessed that particular data? Right. So an example of a data dictionary about personal details of a student can be this. So the field name, data type, field length, constraint, and description. So when we say field name, so field name here is our student ID. Student ID. And our student ID is of a number data type. So the only thing you can type here are numbers. You cannot type names. So if you see student ID and you go and type Kutu, it will not work. And the length here is 5. What this means is that you cannot type 6 digits. You cannot type 6 digits, only 5 digits. Then the constraints. Student ID here is the primary key, and primary keys uniquely identify a tuple in a relation. And description, it refers to a student ID. We will do this subsequently, and we will see how it operates. Then for the second field,
Hello.
student name. Yes, sir.
So your line is breaking.
Hello. Agency. Alex.
So please, it's Shepherd.
Okay. Al Hassan.
Sir,
Is my line shaking?
no, it's clear.
No, it's clear.
Okay.
You should
So
check with
Shepherd,
network.
you can
Yes,
reposition
sir.
yourselves more and see.
Okay. Okay.
Right. So the second field is what we call the student's name. And the data type here is varchar. Varchar. And varchar simply means characters, alphabets, both negative, both upper cases and lower cases. And field length here is 20, which means it can take only 20 characters. So if it is only A's, it will take only A's up to 20. And constraint here, there is no constraint here. Then what is student's name? Student's name is simply the name of the student. We'll do all of this in MySQL Workbench or Access. We'll practicalize it right away. Then student address, also data type is varchar. This also takes 30. Not null, shows the address of the student. My concern is always on the field length. Usually in Microsoft Access, what they give as the minimum is 255. If you choose to leave all that 255 there, what that simply means is that whenever you run your database application, the computer will allocate that chunk of memory, that 255 space in your memory. And what that does is that once you are not using it and you've allocated it, a portion of your memory will be assigned to it. So the portion of memory that is supposed to be doing processing will now be assigned to sort of wait for something to happen. And whilst you are waiting for something to happen, it means you are in use, which means in time, your machine becomes super slow. Right. So that is about that. Let's look at the two types of data dictionary that we know of. We have the active data dictionary and the passive. When we say active, what? Yes, Alex.
Please, I would like you to take me through the constraint again.
Constraints.
Yes.
Right. The concept of keys and those things. So constraints are more or less like restrictions, but we'll look at them in details later when we want to look at entities. Is that okay? So for now, look at constraints as some form of restrictions that can be on a field. Is that
Yes, sir.
okay?
Okay,
But
sir.
we'll look at them in details later. It is broader than mere restrictions or mere concept of keys. Because I also
Okay.
show the foreign key there. There is the entity relations there that we'll also be looking at. And we'll also look at how to enforce what we call referential integrity. And we'll look at all of them. Right.
Thank you,
So
sir.
we have two types of data discipline, the active and the, yeah, you're welcome, Alex. Two types of active, sorry, two types of data discipline, the active and the passive. But broadly, when someone tells you something is active, it simply means that thing is always in execution. You're always doing something, always doing something. But if it is passive, sometimes, oh, I'll work, other times, oh, let me rest more. So passive is more or less like the procrastination attitude. Work more today, tomorrow, oh, let me rest, things like that. Right. So for active, what it does is that it sort of manages only the district, but it does so automatically. Automatically. And most times they work with the relational database management systems. People also call them the integrated. People also call them the integrated. However, for the passive, most times they are done manually. Most times they are done manually. Who are the users of databases? You and I. But you and I are two different kinds of users. We are two different kinds of users. And we are two different kinds of users because what I do with my computer is different from what you do with your computer. And hello.
Hello, sir.
Yes, it looks like I went off for a bit. Okay. So I was asking who are the users of database management systems? Then I said you and I. Then I also said that the way you use your database or the way we use our database management systems will not be the same. So that brings about some concept of the various types of users. So let's look at them one after the other. So right, your books splits them into two: actors on the scene and workers behind the scene. So on the scene, we'll call them front end. Then behind the scene, we'll call them back end. Front end, back end. So first, we'll look at the front end. And typical examples are what we call the database administrators. Yes, and database administrators are actually workers. You go to University of Cape Coast, we have a number of them. We have a number of them. You even go to other institutions, people are employed as database administrators, and they are earning quite a bit. What is their job? Their job is plenty, as you can see here, plenty. But these are just generic. They can be modified. We also have database designers. and their job is similar. However, theirs will be to select and design the appropriate structures, how the database is structured. So they are more into how the database is built, while the administrators are more into how the database is being used for the day-to-day ops and day-to-day administration. Now, when it comes to users too, we have casual end users, those who just use it for 1 or 2 times and go back. We also have the naive or the pragmatic end users. Their responsibility is to sort of just query the database, update it on a regular basis, disappear. Whenever there is another update, they will come through it and go. Sophisticated, the scientists, the engineers, the analysts. So they are those that mostly use the SQL language to come and query the database. They are those that will always come and be scaring us with their command prompt interfaces. They are those that when they come, they speak the language of LS, PS, is it UXF? I've forgotten. Theirs is to come and stand and do 1 or 2 things. Then we also have the standalone end users. What do? They will keep track of some form of personal infos, people's data. Right. We also have the system analyst. System analyst is more of a general computing thing than a database profession. So system analyst is in charge of the day-to-day running or operations of the computer, not merely or only about database. Then we also have the programmers or the software engineers. Behind the scenes, we have the implementers or the designers. We also have the tool developers. Theirs is simple: implement the tools or packages that we can use to monitor, that we can use to test, monitor, test. Then we also have the crew for operators and maintenance. Problem comes, they are your guys. When you are hacked, they are your guys. When you are offline, they are your guys. So that is about the components and elements of DBMS. Let's look at the 4 main types of database management systems. So first is our hierarchical database model. So like the name suggests, it is in a form of a hierarchy. So you take an institution, like say a college, say a college. Within a college, there are departments and institutes or infrastructure. Then within departments, we also have courses, teachers, and students. Then within a course can be theory or lab-based. Then within teachers also, we have various types of teachers. You take the university settings, we have professors, associate professors, senior lecturers, assistant lecturers. Then we also have the senior staffs. They also have their own grades. Then you take students, we have 2 groups of students: undergraduate students and postgraduate students. When you take graduate students too, we also have various types by their programs, then by their departments. You take undergraduate too, we also have various types of undergraduate students. We have the degree students, we have the HND students, we have the diploma students, we also have the certificate students. When you take these various programs too, they also belong to some departments, so those things will also feature. Now, when you go to the infrastructure or units too, we have various types of units, various types of units. So that is what we refer to as a hierarchy. There will always be somebody like a grandfather somewhere overlooking what the children are doing. So that is what the hierarchy is. So for the hierarchy, it comes with some advantages. And what is that advantage? Each node would always only have one parent, and children can't always have a relationship or linkages between them. And that will always make sense from a logical standpoint. And this is what we mean. So a course and a teacher cannot have a relationship. Why? Because a course and a teacher are children of the department, so they cannot have a relationship. Oh, those are disadvantages rather, not advantages. When it comes to advantage, it is easy to access data. Is it there? Well, it's not there, but because of the hierarchical nature in which they are connected, if you are standing here and you are looking for data, you can easily get that data from here or from here. If you don't get it from here or here, you can get it from here or here through this one. That is why I'm saying you can easily access data. Security-wise too, it is okay. Then, of course, your book is also saying that it is through edge, which can be retrieved and manipulated or altered rapidly due to the tree-like structure, tree-like or graph-like structure. Right, then network. So this is what we call the network model. Also in a form of hierarchy, but this one, they are all connected to each other. So preventive maintenance, rigid pavement, flexible pavement, spar repair, joint seal, silicon scalants, and our crack seal patching, and all of them hooked up in the form of a network. Because this is a network connection, this can also be connected to this network connection. And an example of a network connection is an integrated data store. Then where we are right now, or what most of our DBMS are using, is what we call the relational database model, which is made up of tables, which is made up of the concept of tables. So you can have a student file, an assessment file, a program file, and a whole file. We'll create all of this later with MySQL workbench. We also have what we call the object-oriented database model. And for the object-oriented, it is based on the real-world view, where our entities are modeled as objects, just like we have objects in this world. So what you are now seeing as a student file will now become what we call an object. And what is that object? The object will now be here. In this case, pay slip reports. But if we're using student, this would have been student. And this is an object, an object, an object. That is why they simulate a real view of how the system or the world looks like. And they are super good because we can always reuse the various objects that are created. Problem, however, is that it is very costly to develop them. Wahala. Develop them, we need highly skilled personnel to do that, and they are not easily available. Right. So regardless of how the database is structured or how it is used, we'll always have three levels in the concept of what we refer to as schema. So we will have what we call the internal schema, the conceptual schema, and the external schema, which we'll look at the concepts later. However, when we say a physical view, we are interested in how the various records, the various tables are stored on the hard drive. In logical view, we are only interested in how the names, the tables, the attributes, the constraints will be organized. So logical, just an abstract view. physical, how the thing is actually looking. Right. Then we also have the external level, and this is what we call the highest level of abstraction, where what we actually do is to sort of look at the database as a database itself. So like your table summarizes it. For the physical schema, what we look out for are the relations. Are they ordered? Are they unordered? What are the index on these columns? Then for conceptual, we are interested in the concepts. How are the student tables going to be arranged? Then how are the results table going to be arranged? How are the courses table going to be arranged? For the external schema, we are looking at the views. How is the course going to look like? How is the student info going to look like? Right. What is the importance of this database management system? It comes with a lot of efficiency. Why? Because we have to define a schema, and it is this schema that will enable us to either use the DDM, the DDL, or the DML to be able to sort of do whatever we want to do. Database schema. Right. Then it is also versatile. Versatile, which means that we can access it on computers, laptops, tablets, and even our mobile devices. We can also categorize data. We can always restructure it as and when we want it to fit whatever purpose we are looking for. Then multi-access. We can always give access to authorized users as long as they have the credentials. They will be able to log in. We can also create an organized environment by simply putting it online. And then, of course, we will always have newer and better ways to manage data, because whatever DBMS that we are using will always come out with better and newer versions. Importance of database in an organization. It simplifies work. We use it for research. Then it also allows organizations to monitor their progress. It also assists the organization to sort of keep good records on all their activities. Then facilitation of members' data, including their activities. That is including manipulation. All of this is only possible if you have been given access. No access, no data. Then, of course, yes, Paco.
Please, we are new to this subject, so please, the speed in which we are driving, take it slowly for us, please.
Did I say something that you did not understand?
No, I'm getting it, but before I try to, assimilate one, you jump to the next one. So I'm just asking for you. I'm just asking you should slow for us a bit. Thank you.
I have heard you. But if I say something that does not sit well with you, draw my attention. We also do not have all day. We only have 1 hour, 30 minutes. We can find additional time to sort of do 1 or 2 tutorials. That is if the class is okay. Right, so all these are important of DBMS. So you can scroll through them. There's something you don't understand, you let us know and we'll attack it as a team. But one important thing about database management systems is that when it comes to access, it is top-notch, because you need login credentials to be able to log in. Once you don't have the credentials, at best, what you can do is try to hack them. But most of these hacks are often unsuccessful unless you get somebody from the inside to come and help you. And a practical example of that is what is happening with the National Service Authority system, when or where we even have old people being in the system. These old people did not register. These dead people who were even there did not register. Somebody used the back end to drop them inside for their nefarious purposes. But the system in itself is good. Problem is we, the users. So if anything at all, please drop your comments, questions inside. Any questions? I'm supposed to have another class from 3. So we'll end here. Yes, I do, Jennifer.
Okay, sir. So please, the elements of the DBMS, page number 3, the DML, can it also be called database access language?
Access language.
The DML, the elements number 3.
DML.
Um,
The manipulation language.
yes, please. Can you also call it database access language?
Well, in all the books that I have used, they have never said we should call them access language.
Oh, okay.
Yes.
Okay.
Any other questions? Right. So we can end here, but in case you find other time and you want us to meet too, we can gladly do that because we don't have time. Right. So have a good evening.
Okay, sir. Thank you, sir.
All right, so thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Shepherd,
Thank you, sir.
Shepherd,
Sir.
Shepherd, call me.
Hello. Please, is the course right here?
Cause, is
Hello.
it David or your center?
Yeah, David. Is David here?
Oh, he's gone.
Okay, so sir was saying that we should find time and let him meet us. So when do you think will be convenient for us to meet him?
Okay. Shepherd, Shepherd.
Sir, we
Guy.
can make it a Tuesday, right? Tuesday evening, like 7.
Shepherd,
That is what I suggest. Yes.
call me now after this.
Okay, I hear.
Okay, so you can just communicate with David and you contact the lecturer and let him know the time
Yes,
and the.
yes.
All right.
So we will discuss with the lecturer, then we see what we do.
All right. Thank you.
Thank you too.
I don't know my email.